A clinical summary can score high on every automated metric you throw at it and still name a drug dosage that appears nowhere in the source document. A good score, it turns out, is not the same thing as a safe one. Welcome to Amazon Web Services AI Practitioner Prep. Let's finish what that question started. By the end of this video, you'll be able to match the right evaluation metric to the right generative task and know when a score alone isn't enough. This is the evaluation toolkit for generative AI, and the exam expects you to pair each metric with its task on site. Over the last few episodes, we built Beacon Lab's grounded clinical summarizer and climbed the customization ladder to make it behave. And back in episode 4, we worked through the classification metrics, accuracy, precision, recall, and F1 for models that predict a label. But here's the new problem. Those metrics compare a prediction against one known correct answer. When a model writes a summary, there is no single correct answer. So how do you score that? 5 terms anchor everything in this video, so let's establish them now. ROUGE measures overlap between a generated summary and a reference, the go-to metric for summarization tasks. BLEU takes a precision-based approach to the same idea, built specifically for scoring machine translations. BERTScore steps past raw word overlap entirely, using embeddings to compare meaning. A paraphrase scores well even when it shares no words with the reference. Perplexity captures fluency, how surprised a model is by a given sequence of text, where lower surprise means more natural-sounding output. And LLM-as-a-Judge is the practice of using one capable model to score another model's outputs against a defined rubric, at scale. Those 5 set the map for everything ahead. That framing is what splits the evaluation world in two, and the rest of this episode is about filling in the right-hand side of that split. Here's what that split looks like as a working map. Classification metrics on the left, accuracy, precision, recall, F1, stay in their lane when one correct answer exists. Generative metrics on the right, ROUGE, BLEU, BERTScore, and Perplexity are what will build up across this episode. Think of the right column as a preview scaffold. It will fill in as we go, and by the end you'll know which metric to reach for when a scenario describes the task. Let's start with ROUGE, the go-to metric for summarization. The keyword for ROUGE is recall. It asks a coverage question. How much of the reference summary's key content actually made it into the generated one? Did we capture everything important? There are a few flavors. ROUGE 1 counts overlap of single words. ROUGE 2 counts overlap of word pairs. And ROUGE looks at the longest run of words that appears in the same order in both. All of them land on a score between 0 and 1, where higher means more of the reference content was captured. Picture a student taking notes during a lecture, and you want to grade those notes against the official study guide. ROUGE counts how many of the key phrases from that study guide showed up in the notes. The more important concepts the notes covered, the higher the score. That's exactly the recall orientation. The reference is the source of truth, and coverage of it is what gets rewarded. Now flip the orientation, and you get BLEU, the standard for machine translation. Where ROUGE cares about coverage, BLEU cares about precision. It asks, of the phrases the model produced, how many actually appear in the reference translation? It also adds something called a brevity penalty, so a model can't cheat by outputting one perfect word and skipping the rest. Industry guidance puts high-quality machine translation in the 0.4 to 0.5 range, and very high-quality, fluent, adequate output in the 0.5 to 0.6 range. That 0.6 to 0.7 ceiling is actually what 2 skilled human translators score when compared against each other, not a realistic target for machine output. If you're consistently hitting above 0.6, that's worth investigating. It often points to overfitting or a measurement problem. This is the single most important pairing to lock in. ROUGE goes with summarization. It's recall-oriented. It rewards covering the source key content. And its question is, did we capture everything important? BLEU goes with translation. It's precision-oriented. It rewards exact idiomatic matches. And its question is, are the phrases we produced actually correct? Swapping these two was one of the most common errors on this topic. So the reflex is simple. The task tells you the metric. See summarization, think ROUGE. See translation, think BLEU. That pairing rule holds, but both metrics share one blind spot. They count words, not meaning. That's the gap BERTScore is built to close. BERTScore closes that gap by comparing meaning instead of exact words. It uses contextual embeddings from a BERT family model. Remember, embeddings encode semantic meaning as numbers to measure how close two pieces of text are in meaning. That lets it recognize a paraphrase or a synonym that ROUGE and BLEU would mark completely wrong. It still gives you precision, recall, and F1, but at the embedding level, on a scale of 0 to 1. So when a scenario involves a model rephrasing the source in its own words, abstractive summarization, BERTScore is usually the better choice. Look at how stark the difference is. Our reference sentence is, the cat sits on the mat. The candidate is, a feline rests upon a rug. Those two sentences mean the same thing, but they share 0 words. ROUGE 1 scores it 0. BLEU scores it 0. Both surface metrics call it a total miss. But BERTScore gives it 0.91 because in embedding space, cat and feline sit right next to each other, and so do mat and rug. That's the whole value. It understands that different words can carry identical meaning. BERTScore still needs a reference output to compare against, but what if you want to measure quality with no reference at all? That's what Perplexity is for. It measures how surprised the model is by a sequence of text. Lower perplexity means the text reads as more natural and fluent. And because it's intrinsic, measured on the model itself, no reference is required, which makes it useful for comparing two models' fluency head-to-head. But fluency is not correctness. A confident, well-written hallucination can have perfectly low, healthy-looking perplexity. It sounds fine and is still wrong. Let's put all 4 on one map, organized by one scenario. Do you need a reference to compute the metric? On the top left are the surface overlap metrics, ROUGE for summarization and BLEU for translation. Both count word matches, and both need a reference. On the top right sits BERTScore, which also needs a reference but compares meaning through embeddings, so it handles paraphrases. And down at the bottom, standing alone, is Perplexity, the intrinsic one. It needs no reference at all, and it measures fluency where lower is more natural, but never confuse that with more truthful. Those 4 metrics on the map aren't just best practice. They're exactly what the exam guide names. Task Statement 3.4 asks you to identify relevant metrics to assess foundation model performance, and it lists them explicitly. ROUGE, BLEU, BERTScore, and LLM-as-a-Judge. That's the exact terminology the exam uses, so those 4 names are worth committing to memory. And notice the 4th one, LLM-as-a-Judge, which is where we head next. LLM-as-a-Judge is exactly what it sounds like. A model grading another model. You take a capable evaluator model and prompt it to score a generator model's outputs against criteria you define, like correctness or completeness. It works in 2 modes. Pointwise scores a single output on its own. Pairwise looks at 2 outputs and picks the better one. And it's surprisingly reliable. Research puts its agreement with human raters at roughly 85 to 90%. Think of it like hiring a very experienced senior editor to read every article. Instead of leaning on a grammar checker, except this editor works at 100,000 article scale. It's a newer addition to the exam, and it's now available as a managed job type inside Amazon Bedrock. Here's the setup, and it's a two-model pipeline. It starts on the left with your prompt and the criteria you want scored. That feeds the generator model, which produces the output you're actually evaluating. Then that output flows to the judge model, which does two things. It assigns a score, and it explains its reasoning. And that explanation is the part Amazon Web Services emphasizes. As the Bedrock docs put it, the judge scores each prompt and response pair and provides an explanation of how it scored it. So you don't just get a number like correctness 4 out of 5, you get the why behind it, which is what makes the result auditable. But a judge model is not neutral, and you should know its blind spots. It tends to prefer longer, wordier answers, even when they're not better. That's a verbosity bias. In pairwise comparisons, it often favors whichever option it saw first. That's position bias. And it can quietly overrate outputs that match its own writing style. Self-enhancement bias. You mitigate these with structured scoring prompts, and by swapping the order of the two options and averaging the result. Understanding these three biases is what separates a trustworthy evaluation pipeline from one that quietly drifts toward flattering numbers. Step back and you can see 3 tiers of evaluation, arranged from cheap and fast on the left to nuanced and trusted on the right. First, automated metrics, ROUGE, BLEU, and BERTScore. They're fast, cheap, and scale to any volume. Second, LLM-as-a-Judge, which buys you human-like scoring at scale with the human agreement rate we just saw. And third, human-in-the-loop review with benchmark datasets, backed by expert judgments, the tier you reach for when the work is safety critical or regulated. The right answer to an exam scenario is usually whichever tier matches the stakes described. So when do humans and benchmarks become the right call? Human in the loop is your answer for anything safety critical, subjective, or tied to brand voice. The dimensions automated metrics simply can't see. And it's more accessible than people assume, because Bedrock lets you run it with either your own workforce or an Amazon Web Services managed review team. Benchmark datasets are the other piece. Curated, standardized sets like Hella Swag for common sense reasoning or Ain't a Lie for adversarial inference. Because everyone runs the same set, you get reproducible apples-to-apples comparisons. That makes benchmarks especially useful when you're choosing a foundation model before you spend anything customizing it. Both of those, human review and benchmark datasets, map directly to 2 of the 3 official approaches the exam guide names. The third is Amazon Bedrock Model Evaluation, which is where we go next. Amazon Bedrock Model Evaluation packages all of this into a managed service with 3 job types. 2 of them are automated. The programmatic job runs deterministic metrics like BERTScore, F1, accuracy, robustness, and toxicity. The LLM-as-a-Judge job scores quality dimensions like correctness, completeness, and harmfulness, and that capability went generally available in March 2025. The third job type is human-based, where your own workforce or an Amazon Web Services managed team reviews outputs for subjective things like style, tone, and brand voice. Think of it as a fully equipped testing lab you walked into. You bring the test cases, Amazon Web Services provides the instruments and the report. There's no infrastructure to build and no charge beyond the underlying inference cost. So here's how Beacon Labs answered their pharma client, and it's a stack, not a single metric. First, they run programmatic ROUGE scores against human written reference summaries, cheap, fast, over every output. Second, they layer LLM-as-a-Judge to score correctness and completeness at scale, catching the meaning level problems ROUGE misses. Third, they route a random 5% sample through their medical writers for human review, because this is regulated clinical work. And the payoff of all 3 combined is the last step, a repeatable, audible evidence package they can hand straight to the client's regulators. That's what proving accuracy actually looks like. That stack proves model quality to regulators, but there's one more question it doesn't answer. Is the application actually doing its job for the business? That's what business alignment metrics measure, things like task completion rate, user satisfaction, and cost per interaction. These are the numbers a product manager or clinical director actually tracks week to week, sitting a level above model quality scores entirely. And that gap matters. A model can score beautifully on reference overlap and still fail the business if its output doesn't fit how people actually work. Objective 3.4.5 names these explicitly, so when a scenario puts a business stakeholder in the room, these are the numbers they care about. Here's a concrete example that makes it stick. A team ships an AI writing assistant with excellent ROUGE scores. Technically, the summaries are great. Then adoption stays flat, and nobody understands why. They measure task completion rate and user satisfaction, and both are low. The problem? The summaries are correct, but too long for the little card in the interface that displays them. The technical metric was perfect. The business metric revealed the real failure. Always keep both layers in view. Let's lock in the decision reflex. Keep the ROUGE, BLEU, and BERTScore pairing rule in your back pocket. You worked through the recall versus precision logic already, and that's the layer to reach for when a scenario names a task. The one edge case worth flagging again, Perplexity measures fluency, not factual accuracy, so a model can score low perplexity while confidently saying something wrong. When you need human-like scoring at scale, reach for LLM-as-a-Judge. When it's safety critical, reach for human in the loop. The managed path that ties all of it together is Amazon Bedrock Model Evaluation, with its programmatic, judge, and human job types. And above all of those sits the business layer, task completion, user satisfaction, and cost per interaction, because a model that aces every metric but fails the user has still failed. Now let's see how well all of that stuck with a quick 5-question quiz. Question 1. A team has built a machine translation service and wants to evaluate its output against professional reference translations. Which metric is the most appropriate choice? Is it A, ROUGE, because it measures how much reference content is covered? BLEU, because it is a precision-oriented metric designed for translation? C, accuracy, because each translation is either right or wrong? Or D, perplexity, because it measures the fluency of the output? Pause here if you want more time. This one is B. BLEU is the precision-oriented metric built specifically for translation, checking how many of the produced phrases match the reference. ROUGE is for summarization. Accuracy is a classification metric that doesn't apply to open-ended text, and perplexity only measures fluency. Question 2. An abstractive summarizer rewrites source text in its own words. On testing, it produces summaries that are accurate but heavily rephrased, and ROUGE scores come back surprisingly low. Which metric would give a fairer assessment of these paraphrased summaries? A, BLEU, because it rewards exact idiomatic phrase matches. B, perplexity, because it measures how natural the summaries read. C, BERTScore, because it compares meaning using embeddings rather than exact words. Or D, recall on the predicted labels, because summarization is a classification task. Think about which metric understands meaning. It has to be C, and here's why. BERTScore compares meaning through embeddings, so it credits a correct paraphrase that reuses none of the original words. Exactly the case ROUGE penalizes. BLEU would penalize the rephrasing just as harshly. Perplexity only measures fluency. And summarization is not a classification task, so labels don't apply. Question 3. A legal tech firm generates 50,000 contract summaries per week. Reviewing all of them by hand is cost prohibitive, but they still need human-like quality scoring on correctness and completeness. Which approach best fits this scale requirement? A. Route all 50,000 summaries through human reviewers to guarantee quality. B. Use LLM as a judge to score every output, flagging only low-scoring ones for human review. C. Compute perplexity on each summary and reject any above a fixed threshold. Or D. Rely solely on ROUGE scores, since they fully capture correctness. Lock in your answer before I give it away. The right call here is B. LLM-as-a-Judge delivers human-like scoring at scale, roughly 85 to 90% agreement with real raters, so it can score all 50,000 and escalate only the weak ones for human eyes. Full human review breaks the cost constraint. Perplexity only measures fluency, and ROUGE can't judge correctness at all. Question 4. A product team launches an AI summarization feature that scores very high on ROUGE against reference summaries. Yet, adoption is low and users are dissatisfied. Which metric would most likely have revealed this problem before launch? A. Task completion rate, a business alignment metric. B. BERTScore, to confirm the summaries preserve meaning. C. BLEU, to check phrase level precision. Or D. A lower perplexity target to make the text more fluent. Think about which layer the problem lives on. The right call here is A. Task completion rate is a business alignment metric. It measures whether users can actually act on the output, which is exactly what a high ROUGE score can hide. BERTScore, BLEU, and Perplexity are all model quality metrics that would look perfectly healthy here while completely missing the adoption problem. Question 5, and this is the tricky one. Beacon Labs must prove to a regulated pharma client that its clinical summarizer never invents dosage figures. Given the safety-critical, audit-driven requirement, which evaluation approach is the most defensible primary safeguard for the final sign-off? A. Perplexity alone, since low perplexity guarantees the text is factually correct. B. ROUGE scores alone, since high overlap proves the summaries are accurate. C. A high BLEU threshold, since precision guarantees no invented content. Or D. Human-in-the-loop review by medical writers, layered on top of automated metrics. Run the decision rule from earlier before you answer. If you said D, well done. For safety-critical regulated work where an error carries legal and patient consequences, human-in-the-loop review is the most defensible safeguard, ideally layered on top of automated metrics. Watch the traps in the other options. Perplexity measures fluency, not truth, and both ROUGE and BLEU are surface overlap metrics that a fluent, word-matching hallucination can sail right past. None of them can guarantee a dosage wasn't invented. And that's everything on evaluating foundation models, ROUGE, BLEU, BERTScore, and LLM-as-a-Judge for the exam and most of the job. Subscribe for the rest of the Amazon Web Services AI Practitioner prep so you don't lose the thread. Drop a comment on what surprised you. It genuinely shapes future videos. If there's a certification you'd like me to cover, suggest it below. And tell me how the pacing and visuals work for you. Catch you next time.